Pretty much in everything I have been doing here in Switzerland at ETH, Robert Haefeli left his trace. I was surprised. I was not specifically looking to find his legacy, but it was everywhere. I'm really happy that with this time capsule project, we now have the opportunity to bring this contribution to light, and in the hope that it will keep inspiring. The first time I came across the name of Robert Haefeli was in 2004 when I became involved in the stabilization of the Leaning Tower of St. Moritz. The tower is located on a slowly moving landslide, which was first identified by Professor Albert Heim. We know that the tower will survive inclination of about 10%, and our task is to make sure that it does not exceed this inclination. The first stabilization of the tower was undertaken in 1928 by another famous Swiss engineer, Robert Maillard, who was a pioneer of reinforced concrete in bridges and structures. In 1974, Robert Haefeli published a paper where he described his own stabilization attempt. He looked for other famous leaning towers, and of course the Leaning Tower of Pisa was the most interesting one. And in 1968 he performed a second stabilization, anchoring the tower foundations with 4 20-meter long anchors, 300 kilonewtons each, and the drainage was performed with the help of the 3 horizontal shafts. Most likely thanks to Haefeli's anchors, the tower survived the earthquake of 1976. After the death of Professor Haefeli in 1978, responsibility for monitoring and stabilization of the tower went to the Institute of Geotechnical Engineering at ETH Zurich. The third stabilization of the tower in 1983 was performed by lifting the tower from its original foundations and placing it on 2 new foundation berets via concrete collars and 3 Teflon bearing pads. But this is also a temporary solution because you cannot increase the height of these Teflon bearing pads beyond a certain limit. The tower is located on a landslide, on a slowly moving landslide, just at the bottom of it. All our stabilizations implicitly assume that the landslide will not accelerate. But in the mid-90s, after many years of slowing down, the landslide started accelerating without changing groundwater conditions. So looking for potential reasons for this acceleration, we came across another pioneering work by Robert Haefeli. Haefeli was a true scientist. He looked at the problems in the nature, tried to formulate them as mechanical problems, and then solved them as mathematical problems. In the 1940s, he was the first one to identify that pressure caused by the landslide on the retaining structure is not the same as a well-known passive pressure. And in 1944, he published an article in Schweizer Bauzeitung, where he found an elegant approximate solution to this problem. In his original paper, he first tried to identify the types of landslide failure behind the retaining structure. And then, based on these mechanisms, he built mathematical models, and he solved it. It was a theoretical solution. But it appeared to be that the assumptions are pretty reasonable and work for steeper slides. When he became the head of the first soil mechanics lab in Switzerland, Haefeli developed and built most of the testing devices himself. And here, Haefeli developed one of the first ring shear devices in the world to study residual strength on the sliding surface. It's a brilliant idea because landslides, they move many meters down the slope, and the longer they move, the smaller is the strength on the sliding surface. And this is the only device which allows you to shift one part of soil over another part of soil, virtually over an infinite distance, because it's just a rotation. And this tradition is still alive here at ETH. We design and build a lot of our devices, and this is how the latest version of the ring shear device look like. The principle is the same as in Haefeli's device, but we have a lot of sensors here. We managed really to reduce the friction, and we have an ability to perform undrained tests with different velocities. Robert Haefeli was not just a brilliant scientist. These people, they were a generation of founders. They recognized internationally the potential of this science, and they tried to promote it. And Robert Haefeli belongs to this generation of founders. The figure has been growing in my eyes, right? Founder of Geotechnique, a founder of our institute in the soil mechanics lab. In parallel, Robert Haefeli founded the Snow and Avalanche Commission in Davos. He founded a glaciology commission of the Swiss Academy of Science and organized series of international glaciological expeditions to Greenland. And you can see Robert Haefeli here in the middle, bringing different people together. Life is full of surprises. For a while I felt as a pioneer applying soil mechanic principles to snow mechanics, but this didn't last long because pretty soon I came across the PhD thesis of Professor Haefeli, which was titled Snow Mechanics with the reference to soil mechanics. Robert Haefeli is the first and the only geotechnical engineer to have a glacier in Antarctica named after him. Needless to say that at a certain stage I became really curious about Haefeli. I tried to find out more about him as a person, and I was quite lucky because I managed to find his son and his daughter. And I learned about a kind father and a passionate mountain climber and a very talented artist. His family produced a book with his drawings, most of them made during his trips to the mountains. All these accomplishments we need to assess against the background of his really poor health. He had a very severe depression which started and ripped him off really at the peak of his scientific career. His daughter told me that the most difficult thing was to watch him being so sad all the time. And yet, every time when doctors managed to stabilize him, he fought back. He had more than 100 publications in this time, in these rare, bright periods. At a certain point, I realized that whatever I do here, I somehow fall into his steps. I do not have a fully rational explanation for this. Maybe this is indeed a bit of a mystery, because I recently realized that I live just a few hundred of meters away from his house where he used to live. And I have passed it hundreds of times without realizing it. I have enormous respect and admiration for him. And I hope that his life and work will inspire young geotechnical engineers for many generations to come. I wish we had more scientists like him today.